Let us evaluate the definite integral 9x squared minus 4x plus 1 dx from 2 to 4. So to solve this, we must first get our antiderivative. So for 9x squared, it will be 9x cubed over 3. And then you have minus, for 4x, it would be 4x squared over 2. And then for plus 1, it will be plus x. And this will be evaluated from 2 to 4. So let us simplify. 9 over 3, x cubed will be 3x cubed. And then negative 4 over 2x squared will be negative 2x squared. And then you have plus x evaluated from 2 to 4. So we must first substitute our upper limit of integration. That would be 4. So we substitute that to every x in our resulting antiderivative. And then we substitute our lower limit of integration, which is 2. So again, we put that on every x in our antiderivative. So the first term, when we solve this, we get 164. And then for the second term, when we compute this one, we will be getting 18. So 164 minus 18, we get 146. So our antiderivative, our definite integral of 9x squared minus 4x plus 1 dx from 2 to 4 is 146. For our second example, let us evaluate the definite integral of 4 sine x plus 3 secant x tangent x dx from 0 to pi over 3. So we will be evaluating this term by term. So we start with 4 sine x, we copy the coefficient 4, and we multiply this with our antiderivative for sine x, and this is negative cosine x. We don't need to use a substitution rule because our trigonometric functions here are just basic in form. So for the second term, we just copy 3. We already have a formula for secant x tangent x, and that is secant x. So we want to evaluate this from 0 to pi over 3. So let us simplify this first. So 4 times negative cosine x is negative 4 cosine x. And then 3 times secant x is just 3 secant x. So again, we evaluate this from 0 to pi over 3. So our upper limit of integration is pi over 3. So we evaluate the expression first with, using pi over 3. So we get negative 4 cosine of pi over 3 plus 3 secant of pi over 3. Next, we substitute 0, our lower limit of integration. So we have negative 4 cosine of 0 plus 3 secant of 0. So we continue. We have negative 4 cosine of pi over 3 is 1/2 plus 3 secant of pi over 3 is 2. Next, we have, so we copy negative 4. Cosine of 0 is 1. And then we copy 3. Secant of 0 is also 1. So if we compute the first term, we will be getting 4. And for the second term, so we will be getting negative 1. So this is minus negative 1. And so our final answer will be 5. So the definite integral 4 sine x plus 3 secant x tangent x dx evaluated from 0 to pi over 3 is equal to 5. If you want to use your calculator, the function in your calculator evaluating definite integrals, so for number 1, your calculator can be either in the degree or the radian mode. But for the second given, because it's trigonometric, so you have to make sure that your calculator is in the radian mode before you compute the definite integral. this time, let us evaluate definite integrals that require substitution rule in finding the antiderivative. So for number 3, we have the definite integral of x over the square root of 10 minus x squared dx from 1 to 3. So if we perform the substitution, we let u be the base, 10 minus x squared, and then we get du is equal to negative 2x dx. So in order for the substitution to work, we are going to put negative 2 in our given and supply a correction factor of negative 1/2 outside of the integration sign. This means our given will be converted into negative 1/2. So we have negative 2x dx will be converted into du. And then we have for the denominator, it will be square root of u. For the limits of integration, since 1 and 3 are intended for the variable x, we are going to find the equivalent values for u using the substitution that u is equal to 10 minus x squared. So if x is 1, so for the lower limit of integration, so 1, if x is 1, then we find that u is equal to 10 minus 1 squared using this substitution, and that would give us 9. And using the upper limit of integration, so if x is equal to 3, we substitute 3 to x in 10 minus x squared. So that would be 10 minus 3 squared, or 10 minus 9. So we get the corresponding value of u, and that would be 1. So we're going to use that in our substituted form. So the lower limit, instead of putting 1, we are going to use its equivalent value in u, and that would be 9. And then for the upper limit of integration of 3, we are going to use its equivalent value in u, and that would be 1. So let us try to write this in the power form. So we have negative 1/2 u raised to negative 1/2 du. So our new upper and lower limits of integration are 1 and 9 respectively. So if we perform the power rule, we get negative 1/2 u raised to negative 1/2 plus 1 is u raised to 1/2 over 1/2, and then we evaluate this from 9 to 1. Simplifying, we cancel 1/2, so this will become negative square root of u evaluated from 9 to 1. So we initially put our upper limit of integration, and that is 1. So we get negative square root of 1 minus, this time we substitute our lower limit of integrations, it will be negative square root of 9. So this gives us negative 1 minus negative square root of 9. So that would be 3. And the final answer is 2. So the value for our definite integral of x over the square root of 10 minus x squared dx from 1 to 3 is 2. So let's have another example. This time we have a trigonometric function. We have cosine of 4x dx evaluated from 0 to pi over 8. Using the substitution rule for trigonometric functions, we let u be the angle for x, and then we get du is equal to 4 dx. So we supply our coefficient 4, and then the correction factor is 1/4, thereby converting our given into 1/4, and then you have cosine of u, and then 4 dx will be transformed into du. Now, since 0 and pi over 8 are intended for the variable x in the given, and we have substituted our given in by u, so we need to get the equivalent value of x in u. So if x is equal to 0, our lower limit of integration, so substituting 0 on our expression for u, which is 4x, we find that u is also 0. Now, if x is equal to pi over 8, our upper limit of integration, then the corresponding value of u, so 4 times pi over 8, we get pi over 2. So these are the values of the lower and upper limits of integration that we are going to apply on the substituted form. So instead of writing 0, the lower limit, well, it's also 0. And then for the upper limit of integration, instead of writing pi over 8, we're going to use the equivalent of that in u, and that would be pi over 2. Then we evaluate, so we copy the coefficient. Our integral for cosine of u is sine of u. Then we evaluate this from 0 to pi over 2. So we first substitute our upper limit of integration, that would be pi over 2, minus, this time we substitute our lower limit of integration, so we get sine of 0. Continuing, we have 1 over 4, sine of pi over 2 is 1, minus, again we copy 1 over 4, sine of 0 is 0. So solving this one gives us our final answer of 1 over 4. So the value of the definite integral cosine 4x dx from 0 to pi over 8 is 1 over 4.